let's say that you have 20 runners in a marathon. And let's say at the end of the race, there's first, second, and third place allotted. So the question is, how many different ways are there to allot these 3 prizes among the 20 runners? So if you don't know where to start, what I would highly recommend is don't just say, is this a C or a P? What I recommend is starting from first principles. Start with trying to list out all the possibilities, at least list out a few, so that you can see what the structure of the pattern is. So, for example, if we were to start listing out the possibilities, and we tried to keep them straight, one possibility for who gets first, second, and third prize might be, if you number the 20 runners, for example, runner number 12 might get first place in one possibility, and then runner number 7 might get second place, and then runner number 18 might get third place. This is one possibility that ends up getting counted. If you're to list out all the possibilities, then let's list out another one. Then these 2 example possibilities has how many objects in them?
3.
Yeah. So they have 3 objects each, so every possibility must have 3 objects or 3 placeholders. And those 3 placeholders represent getting first, second, and third place. So every possibility has, you're keeping track of which runners get first, second, and third place. So for the first placeholder, yeah.
20, 19, 18?
Yeah, very good. So for the first placeholder, how many options of runners are there
20.
to possibly get first place? So there's 20 options for who could get first place. So once you identify who gets first place, how many options of runners now could get second place?
19.
Yeah, 19. Okay. And then 18. So this is the same as saying how many different groups of 3 runners are possible from 20. But now you have to ask yourself, should order matter? Do you want order to matter? And this is important, and in order to answer that question correctly, look at one of the example possibilities that you had, and take the same 3 numbers, but order them in a different order. So let's say that we have, now we're gonna take the same 3 numbers, but put them in a different order. Should these count as 2 different possibilities, or the same possibilities, because it's the same 3 runners?
2 different possibilities.
2 different possibilities, because this order is actually has meaning. Because in the first case, runner number 4 is getting first place, but in the second case, runner number 9 is getting first place. So these are actually 2 different possibilities that should be counted differently. So we say that order matters, because it's the same 3 numbers, but we want to count the different orderings as different possibilities. So because order matters, we would just multiply these 3 and then stop. So basically, this is a permutation, where this is 20 permutation, 3 numbers total. So this is 20 permutation 3, and we want to stop here. We don't want to divide out in order to get the total number of columns. So we care about the order. So the answer here would be 20p3. Any questions?
6,800.
What is it?
6,840.
6,840. Okay, thanks. Okay, good. So I know time is technically out, but give me another minute, just so that you can contrast this, and it'll help you out on the moment. So let's say on your next example, let's say that you have 15 basketball players. But let's say that there's only room on the court for 5 players at a time. So you want to pick a team of 5 players. So the question is, how many different teams of 5 players are possible from 15?
Would be 15 people.
Okay, so let's talk about it. So the most common answer happens to be 3, which is, you take, students often take 15 and then divide by 5, and they get 3. This is actually the correct answer to a different question, which is, if you were to be asked how many different teams of 5 players can play on the court at the same time, then that would be 3 different teams. Because you can divide these 15 players up into 3 different teams that play at the same time. But that's not what we're asking. We're asking if only one team can play at a time, then hypothetically, how many different teams of 5 players can there be? So if you start listing them out, one team might consist of player number 7, and then 2, and then 12, and then 3, and then let's say 15. Let's say this is one example team. So the question is, how many such teams are there?
3003.
What expression did you use?
Combination, right?
Okay, very good. So at this point, this reduces down to the question of how many groups of 5 numbers are there from 15 numbers. So, but then you have to ask, do you care about order within each group of 5 or not? So to answer that question, imagine taking the same 5 numbers or the same 5 players and changing the order of the numbers. So if you change the order, I'm just going to pick some arbitrary order here. Should these represent 2 different basketball teams, or are they the same basketball team? They're the same, because all we're doing is changing the order of the players, but they're the same 5 players. So if you want order to matter, that's a permutation. If you want order to not matter, that's a combination. So this should be 15 combination 5 or 15 choose 5. Any questions?